Okay, welcome back to the course on uh, digital signal processing. We have been discussing about the Z transformations. We know the direct formula for finding the Z transform of a finite duration sequence, so not it's a time domain sequence x of n. Then Z transform is x of z is a function of a power series. So here it's an infinite power series. It exists only for uh, those values of z for which the series converges. So we'll call it as the region of convergence. So the region of convergence of x of z is the set of all values of z for which x of z attains a finite value. So which is if all the values of z for which x of z attains a finite value. So we can see we can call that region as a region of convergence. So anytime we cite z transform, then we should also indicate its region of convergence. And so region of convergence is nothing but it is the set of all values of z for which the x of z has a finite. See here, if you apply one value for z, then where this series will converge. Say for example, in this case, here we have an imaginary axis and this is the real axis of z. So here we will try to find out the values of z where the x of z is having a finite value, and that is what we call it as the region of convergence. Now we will see one problem, then we can easily find out. Here I have illustrated some problems, and we need to determine the z transform of these following finite duration sequences. And the first problem is x of n is equal to 1, 2, 5, 7, 0 and 1, and we will try to find out if you apply these values of x of n into the above formula. That is, in this formula, if you apply the values of x1 of n into this formula, what happen? Then you will get x1 of z is equal to 1. That is when z is a finite duration sequence. The sequence will starts from 0, 1, 2, 3, 4, 5, 6, 7, etc. It's a finite duration sequence. It contains some 6 elements. Now if the value of n is having different values, when n is equal to 0, then it's equal to 1 in x1 of n into z raised to 0. When n is equal to 1, then it becomes 2 into x1 of n is equal to 2 into z raised to minus 1 plus 5 into z raised to minus 2, etc. So at last we'll get z raised to minus 5. So that's the x of z. Then what's the region of convergence? That means the region of convergence is where these z will get the finite, x of z becomes a finite value, the value of z at which x of z becomes a finite value. And here in this case the region of convergence is the entire z plane except at z is equal to 0. What happens when z is equal to 0? Then see, for example, in this case it's 2 into z raised to minus 1. 2 into z raised to minus 1 means it's equal to 2 divided by z raised to 1. That means when you give the value of z is equal to 0, then it becomes 2 by 0. 2 by 0, it's not defined. It's maybe it's not yes. 0 raised to 1, 0 raised to 2, 0 raised to 3. So it's the entire z plane. Entire values of z are valid except it is z is equal to 0. And the second case, it's x2 of n 1 2 5. So here the series starts from the origin is indicated here in at 5. Then what happens is the series becomes z square plus 2z plus 5 into z raised to minus 1 to into z raised to. So in this case, when we apply z is having if z is equal to infinity, then what happens? It's infinity raised to 2, and again it's not valid. It will not give you a finite value for x of z when z becomes 0 here. It says 0 raised to minus 1 and 0 raised to minus 3. All these values are not possible. That's again the third one. Again here 0 0 1. In this case again same as the earlier one. Its region of convergence is entire z plane except this as it is z is equal to 0. In the fourth case it is 2 4 5, again just like the problem second problem B. And the fifth one, it's x5 of n is equal to delta of n. Delta of n means it's equal to 1. So region of convergence is entire z plane. Entire values of z is having will give you a finite value for the z transform, or x of z will get a finite value. And the sixth problem, this is x of n. X6 of n is delta of n n minus k. That means here we'll get it's a shifted version of the impulse signal, and in this case it will get the z transform as z raised to minus k. Z raised to minus k, its region of convergence is again entire z plane except z is equal to 0. When the value of z becomes 0, then it's not a finite. X of z is not a finite value. The last one, x of n plus 1, again it's an advanced signal, so its region of convergence is at z is equal to minus infinity. Okay, I hope you understand the concept of these regions.